All right, so in this last problem, we're looking at something a little bit different because it has pulley systems, but you'll find out it's basically the exact same thing. It says for the diagram below, the coefficient of friction is 0.05. Find the velocity of the system and the distance the system moves in 3 seconds. Gives us a time, that's good. And starting from rest, so we know that it's not moving when it begins. It gives the mass of each of the three masses that we're looking at. Only one is actually going to be experiencing friction because the other two are hanging. You can get the gist of which direction it's moving in based on which one of these is more massive because they're both affected by gravity's acceleration equal. So it should be moving towards M3. And what you really need to understand is this tension force and the simple machine of a pulley, really it just changes direction. So if you can think about this as a straight line that moves like that. Now that it's a straight line, even though that's a curved line, it's a straight movement. You can think about it as just forces in these directions adding together, right? And so that makes it a little bit more simple for us to come up with a net force system where we say that all of the masses, because one couldn't be accelerating faster than the other if they're linked together, will be accelerated at the same time. So that will give us a net force. But also the sum of all the forces will give us a net force. That sum is what we're going to look at first because, like I said, this M1 will be the only one that has friction, but both of these others have a force due to gravity on them. So I'm just going to call that force due to gravity on each of those the force of that number. So we said M3 would be the largest, so F3 minus the frictional force minus the force of the second one. We can solve for each one of these because we know enough information. I started with this frictional force, and I knew a couple of things first. The frictional force is equal to the normal force times the coefficient of friction. Normal force is equal to gravity. Since it's not at an angle, it's pretty much straight up and down, other than it is magnitude, not direction. And gravity is real easy. It's just mass times gravity, right? Acceleration due to gravity. So I rewrote this as F of k is equal to the force of gravity of mass number 1 times the coefficient of friction. Broke it down again, so you see that is mass times little g times coefficient of friction. Plugged in all my values, got 24.5 newtons. The other two are very simple. They're just gravity formulas with the different masses. Plugged in those things, got my two different forces for each one of those. Notice F3 is the largest. That's why we take it and subtract the other two from it. And so what we're going to do is we plug all of those into that net force formula. F3 minus friction minus F2. You get a net force of 24.5 newtons. Well, that's good because if we then know the total mass, we just divide by that and we'll have the acceleration. Added all the masses together, 50 plus 25 plus 30 equals 105. And so I did 24.5 newtons divided by 105 grams, and I got an acceleration of 0.233 repeating meters per second squared. That can now be used with the time to solve both of our velocity and our distance questions. We just need some kinematics. That's right, it doesn't go away, it comes back to haunt you in your dreams. So using the first kinematic problem here, final velocity is equal to initial velocity times acceleration times time, or plus acceleration times time. I can go ahead and get rid of that initial velocity because we said it started at rest. Makes it super easy. The acceleration we just had times 3 seconds gives us our final velocity of 0.7 meters per second. I then used the second formula, even though it had what seemed to be a lot bigger stuff and more involved. It's just df is equal to di plus vi times t plus 1/2 of a times t squared. But since velocity initial is 0, we get rid of that term. Since we're starting at 0 because we're just concerned at how far it went, we'll make that 0. And then we only have a few things to plug in. 1/2 of our acceleration times 3 squared. Multiply all that together, I got that it went 1.05 meters. So see, fairly simple, since you know how to do kinematics, once we solved the net force and figured out what we needed to put in it. And that's all of them.